John B. Watson's revolution did not transform psychology overnight. It took a bit more time than he expected. Yet by 1924, little more than a decade after he formally launched behaviorism, even Titchener, Watson's greatest opponent, conceded that behaviorism had taken over American psychology. By 1930, Watson was able to proclaim with considerable justification that his victory was complete. Watson's behaviorism was the first stage in the evolution of the behavioral school of thought. The second stage, neo-behaviorism or new behaviorism, dates from 1930 to about 1960, a 30-year span, and includes the work of Tolman, Hull, and B.F. Skinner. These new behaviorists agreed on these points. The core of psychology is the study of learning. Most behavior, no matter how complex, can be accounted for by the laws of conditioning, and that psychology must adopt the principle of operationism. The third stage in behaviorism's evolution, neo-behaviorism, or what is called neo-behaviorism or new behaviorism or socio-behaviorism, dates from about 1960 to about 1990. And so you have neo or new behaviorism from 1930 to 1960, a 30-year span, and then you have the neo behaviorism or the new behaviorism or socio-behaviorism from 1960 to 1990, another 30 years. This neo-behaviorism or socio-behaviorism includes the work of Bandura and Rotter and is distinguished by a return to the consideration of cognitive processes while maintaining a focus on the observation of overt behavior. Those second and third stages of behaviorism will be covered in the next readings. But first, let's look at operationism. The purpose of operationism, which was a major characteristic of neo-behaviorism, was to render the language and terminology of science more objective and precise and to rid science of pseudo-problems. That is, those problems that are not actually observable or physically demonstrable. Operationism holds that the validity of any scientific finding or theoretical construct depends on the validity of the operations used in arriving at that finding. Again, the operationism is the doctrine that a physical concept can be defined in precise terms related to the set of operations or procedures by which it is determined. The operationist viewpoint was promoted by Percy W. Bridgman, a Nobel Prize-winning physicist at Harvard University who lived from 1882 to 1961. His book, The Logic of Modern Physics, published in 1927, captured the attention of many psychologists. Bridgman insisted that physical concepts must be defined precisely and that all concepts lacking physical reference to the actual world had to be discarded. We may illustrate by considering the concept of length. What do we mean by the length of an object? We evidently know what we mean by length if we can tell what the length of any and every object is, and for the physicist, nothing more is required. To find the length of an object, we have to perform certain physical operations. The concept of length is therefore fixed when the operations by which length is measured are fixed. That is, the concept of length involves as much as, and nothing more than, a set of operations. The concept is synonymous with the corresponding set of operations. Thus, a physical concept is the same as the operations or procedures by which it is determined. Many psychologists believed this principle would be used or useful for their work and were eager to apply it. Bridgman insisted on discarding pseudo-problems, those questions that defy answer by any known objective test, and it was particularly appealing to behavioral psychologists. Propositions that cannot be put to experimental test, such as the existence and nature of the soul, are meaningless for science. Can the soul be observed in the laboratory? Can it be measured and manipulated under controlled conditions to determine its effects on behavior? And this is something that David Hume asked as well. If not, then the concept has no use, meaning, or relevance for science. That is not the same as saying that there is no such thing as the soul, but simply that it cannot be operationalized. Following this reasoning, the concept of individual or private conscious experience is also a pseudo-problem for the science of psychology. The existence or characteristics of consciousness cannot be determined or even investigated by objective methods. According to the operationist viewpoint, then, consciousness has no place in a scientific psychology. Critics suggested that operationism was little more than a formal statement of principles that were already being used by psychologists to define ideas and concepts in relation to their physical reference. There is little in Bridgman's book on operationism that cannot be traced to the works of the British empiricist. We think about David Hume, or rather also Berkeley and Locke. We also think about the rationalists like Leibniz and Descartes before them. There is little in Bridgman's book on operationism that cannot be traced to the works of the British empiricists. And then think of the empiricists as well, like John Stuart Mill. The long-term trend in American psychology was, as we have seen earlier, toward greater objectivity in methodology and subject matter, so it can be said that the operationist approach to research and theory had already been accepted and put into practice by many psychologists. Since the days of Wilhelm Wundt in Germany, however, physics had been the paragon of scientific respectability for the newer psychology. When physicists proclaimed their acceptance of operationism as a formal doctrine, many psychologists felt compelled to follow this role model. Eventually, psychologists used operationism more extensively than did physicists. As a result, the generation of neo-behaviorists that came of age in the late 1920s and 1930s included such individuals as B.F. Skinner, who incorporated operationism in their approach to psychology. Bridgman lived long enough to witness not only psychology's embrace of operationism, but also the later discarding of his approach. At the age of 79, knowing he was terminally ill, he completed the index to a 7-volume edition of his collected writings, mailed it to the publisher, and shot himself. He had feared that if he waited any longer, he would become incapacitated and unable to take such action. In his suicide note, he wrote, "Probably this is the last day I will be able to do it myself." End quote. Edward Chance Tolman, 1886 to 1959. One of the early converts to behaviorism, Edward Tolman studied engineering at the Massachusetts Institute of Technology. He switched to psychology and received his Ph.D. from Harvard in 1915. In the summer of 1912, Tolman studied in Germany with the Gestalt psychologist Kurt Kafka. In Tolman's final year of graduate school, he became acquainted with Watson's new behaviorism, which he said came as a tremendous stimulus and relief. Tolman became an instructor at Northwestern University in Evanston, Illinois, and in 1918 took a new position at the University of California at Berkeley. It was at Berkeley where he taught comparative psychology and conducted research on learning in rats that he became dissatisfied with Watson's form of behaviorism and began to develop his own. During World War II, Tolman served with the Office of Strategic Services, the OSS, the forerunner of the Central Intelligence Agency, also known as the CIA. In the early 1950s, he helped lead faculty opposition to the new California State Loyalty Oath. Tolman's approach to behaviorism was put forth in his book titled Purposive Behavior in Animals and Men, published in 1932. His term purposive behaviorism may appear at first glance to be a curious amalgam of two contradictory ideas, purpose and behavior. Again, purposive behaviorism is Tolman's system combining the objective study of behavior with the consideration of purposiveness or goal orientation in behavior. So Tolman's system, it combines the objective study of behavior with the goal orientation in behavior, goal-oriented beings. So, attributing purpose to an organism's behavior seems to imply consciousness, a mentalistic concept that has no place in a behavioral psychology. Tolman made it clear, however, that he was very much the behaviorist in subject matter and methodology. He was not urging psychology to accept consciousness. Like Watson, he rejected introspection and had no interest in presumed internal experiences that were not accessible to objective observation. Tolman argued that purposiveness in behavior can be defined in objective behavioral terms without resorting to introspection or to reports about how one might feel about an experience. It seemed obvious to Tolman that all actions were goal directed or goal oriented. For example, an example of all actions that are goal directed or goal oriented. A cat tries to find its way out of the psychologist's experimental puzzle box. A rat tries to master the maze, and a child tries to learn to play the piano or to kick a ball. In other words, Tolman said behavior reeks of purpose and is oriented towards achieving a goal or learning the means to an end, and so therefore behavior has a goal-oriented end. And so what is happening in this case is that the rat is learning, and the fact of learning, whether in animal subjects or human subjects, is objective behavioral evidence of purpose or some kind of teleological meaning. So note that Tolman is dealing with the objective responses of the organism, and that the measurements are stated in terms of changes in response behavior as a function of learning. These are measures that yield objective data. Watsonian behaviorists were quick to criticize the attribution of purpose to behavior. They insisted that any reference to purposiveness implied recognition of conscious processes. Tolman responded to that by saying that it made no difference to him whether the person or the animal was conscious. The conscious experience, if there was any, associated with purposive behavior, did not influence the organism's behavioral responses, and Tolman was interested only in overt responses. As a behaviorist, Tolman believed that both the initiating causes of behavior and the final resulting behavior must be capable of objective observation and operational definition. He listed 5 independent variables as causes of behavior. First was environmental stimuli. Second was physiological drives. Third was heredity. Fourth was the previous training. And fifth was the age of the individual. So behavior is a function of these 5 variables: environmental stimuli, physiological drives, heredity, previous training, and age. An idea Tolman expressed in a mathematical equation. Between these observable independent variables and the resulting response behavior, the observable dependent variable, Tolman inferred a set of observable factors, the intervening variables, which are the actual determinants of behavior. These factors are internal processes that connect the stimulus situation with the observed response. So, intervening variables are unobserved and inferred factors within the organism that are the actual determinants of the behavior. So, the behaviorist SR, or stimulus response proposition, should read SOR. So far as Tolman was concerned, the intervening variable is whatever is going on within. The O. The O is the organism that brings about the behavioral response to a given stimulus situation. So really, it is stimulus organism response. But because intervening variables cannot be objectively observed, they are of no use to psychology unless they can be directly related to the experimental or the independent variables and the behavior, the dependent variable. So the classic example of an intervening variable is hunger. We cannot actually see hunger in a person or a laboratory animal, but hunger can be precisely and objectively related to an experimental variable, such as the length of time since the organism has last received food. Hunger can also be related to an objective response or behavior variable, such as the amount of food consumed or the speed with which it was eaten. Thus, the unobservable variable of hunger can be described precisely in relation to empirical variables and made amenable to quantification in experimental manipulation. By specifying the independent and dependent variables, which are observable events, Tolman was able to provide operational definitions of observable internal states. He initially referred to his approach in general as operational behaviorism before selecting the more precise term intervening variable. The problem of learning formed a major part of Tolman's purpose of behaviorism. He rejected Thorndike's law of effect. And of course, we've already gone over Thorndike. And Tolman said that reward or reinforcement has little influence on learning. In its place, Tolman proposed a cognitive explanation for learning, suggesting that repeatedly performing a task strengthens the learned relationship between environmental cues and the organism's expectations. In this way, the organism gets to know its environment. Tolman called these learned relationships sign gestalts and pointed that they are built up by the continued performance of a task. As an example, consider a hungry rat in a maze. The rat moves about in the maze, exploring correct alleys and blind alleys. Eventually, the rat discovers food. In subsequent trials in the maze, the goal of finding food gives purpose and direction to the rat's behavior. Expectations are established at each choice point in the maze, and the rat comes to expect that certain cues associated with each choice point will or will not lead to the food. When the rat's expectation is confirmed and it obtains food, the sign gestalt, which is the cure expectancy associated with the particular choice point, is strengthened. For all the choice points in the maze, then the animal establishes a cognitive map, which is a pattern of sign gestalts. This pattern is what the animal learns. It learns the map of the maze, not merely a set of motor habits. The rat's brain forms a comprehensive picture of the maze or of any familiar environment, enabling it to go from one place to another without being restricted to a fixed series of bodily movements. Tolman concluded that the same phenomenon occurs with people familiar with their neighborhood or their town. They can go from one point to another by several routes because of the cognitive map they have developed within their own mind. And so Tolman is recognized as a forerunner of contemporary cognitive psychology. We will go over cognitive psychology later on in our reading. But his work had a great impact, especially his research on problems of learning and his concept of the intervening variable. Intervening variable of the SR response, the stimulus response, putting O in the middle, it is stimulus organism response. SOR. So, with that being said, because intervening variables are a way of operationally defining observable internal states, they made such states respectable subjects for scientific study. Intervening variables were used by neo-behaviorists such as Hull and Skinner, which we will go over next. So, with that being said, another significant contribution was Tolman's wholehearted support for the rat as an appropriate subject for psychological study. At the start of his career, Tolman was not enthusiastic. He said about rats, quote, "I don't like them. They make me feel creepy," end quote. And that was Tolman in 1919. But by 1945, his attitude had changed. He said, "Let it be noted that rats live in cages. They do not go on binges the night before one has planned an experiment. They do not kill each other off in wars. They do not invent engines of destruction. And if they did, they would not be so inept about controlling such engines. They do not go in for either class conflicts or race conflicts. They avoid politics, economics, and papers on psychology. And they are marvelous, pure, and delightful," end quote. And that was Tolman in 1945, the year that World War II ended. So thanks to the work of Tolman and others, the white rat became the primary research subject for the neo-behaviorist and learning theorist from 1930 to the 1960s. It was assumed that research on white rats would yield insights into the basic processes underlying the behavior not only of rats but also of other animals, including humans. Tolman wrote that, quote, "Everything important in psychology can be investigated in essence through the continued experimental and theoretical analysis of the determiners of rat behavior at a choice point in a maze," end quote. Now, who needed human subjects when so many white rats were available? Clark Leonard Hull, 1884 to 1952. Clark Hull and his followers dominated American psychology from the 1940s until the 1960s, so perhaps a period of about 20 years, about two decades. Perhaps no other psychologist was so devoted to the problems of the scientific method. Clark Hull had a prodigious command of mathematics and formal logic, and he applied these disciplines to psychological theory in a way no one had done before. Hull's form of behaviorism was more sophisticated and complex than John Watson's. Hull liked to tell his graduate students that, quote, Watson is too naive, his behaviorism is too simple and crude, end quote. Throughout his life, Hull was plagued by ill health and poor eyesight. As a boy, he nearly died from typhoid, which left his memory impaired. When he was 24, he contracted polio, which left him with a permanent disability in one leg, forcing him to wear an iron brace, which he designed himself. His family was poor, and Hull was forced to interrupt his education several times to take teaching jobs to earn money. His greatest asset was an intense motivation to succeed, and he persevered in the face of many obstacles. In the year 1918, at age 34, Hull received his Ph.D. from the University of Wisconsin, where he studied mining engineering before changing to psychology. He remained on the Wisconsin faculty for 10 years. His early research interests foretold his lifelong emphasis on objective methods and functional laws. Hull investigated concept formation, the effects of tobacco on behavioral efficiency, and tests and measurements, and he published a textbook on aptitude testing in 1928. He developed methods of statistical analysis and invented a machine for calculating correlations, which has been exhibited at the museums of the Smithsonian Institution in Washington, District of Columbia. He devoted 10 years to the study of hypnosis and suggestibility, publishing 32 papers and a book summarizing the research. In 1933. In 1929, Hull accepted a position as research professor at Yale University to pursue his interest in formulating a theory of behavior based on Pavlov's laws of conditioning. He had read Pavlov's work a few years earlier, and he had become intrigued by conditioned reflexes in learning. Hull referred to Pavlov's conditioned reflexes as a great book and decided the odors associated with a rat lab. He thought that Pavlov's conditioned reflexes as a great book and decided to use animal subjects for his research. He had not run rats before because he detested the odors associated with the rat lab, but at Yale he visited the meticulously clean rat colony maintained by E.R. Hilgard. Hull looked at the rats, sniffed them, and said that he guessed he could use rats after all. In the 1930s, Hull published articles about conditioning, arguing that complex higher-order behaviors could be explained in terms of basic conditioning principles. Hull's book in 1943, titled Principles of Behavior, outlined a comprehensive theoretical framework to account for all behavior. Hull soon became the most frequently cited psychologist in the field. In the 1940s, up to 40% of all experimental articles and 70% of all articles on learning and motivation in the two leading American psychology journals cited Hull's work. Hull continually revised his system, incorporating the results of his extensive research that put his propositions to experimental test. The final form was published in 1952 in a behavior system. So Hull described his behaviorism and his image of human nature in mechanistic terms and regarded human behavior as automatic and capable of being reduced to the language of physics. According to Hull, behaviorists should regard their subjects as machines, and he described to the view far in advance of the development of computers. He believed that machines would one day be constructed to think and display other human cognitive functions. In 1926, Hull wrote, quote, "It has struck me many times that the human organism is one of the most extraordinary machines, and yet a machine. And it has struck me more than once that so far as the thinking processes go, a machine could be built which would do every essential thing that the body does." End quote. We can see that the 17th century spirit of mechanism, as represented by Europe's mechanical figures, clocks, and automata like the defecating duck, was faithfully incorporated into Hull's work. Hull's mechanistic, reductionistic, and objective behaviorism provided a clear view of what his methods of study had to be. First, they would be objective. In addition, they would be quantitative, with the fundamental laws of behavior expressed in the precise language of mathematics. Hull considered 4 methods useful for scientific research. 3 were already widely used: simple observation, systematic controlled observation, and the experimental testing of hypotheses. The 4th method Hull proposed was the hypothetical deductive method, which uses deduction from a set of formulations that are determined by establishing postulates from which experimentally testable conclusions can be deduced. Again, the hypothetical deductive method was Clark Hull's method for establishing postulates from which experimentally testable conclusions can be deduced. So, these conclusions are submitted to experimental test, and they must be revised if they are not supported by experimental evidence. If they are supported and verified, then they may be incorporated into a body of science. Hull believed that if psychology were to become truly objective, like the other natural sciences, which was a basic principle of the behaviorist program, then the only appropriate method would be the hypothetical deductive one, which establishes postulates from which experimentally testable conclusions can be deduced. So, to Hull, the basis of motivation was a state of bodily need that arose from a deviation from optimal biological conditions. Rather than introducing the concept of biological need directly into a system, however, Hull postulated the intervening variable of what he called drive, a term that had already come into use in psychology. Drive was defined as a stimulus arising from a state of tissue need that arouses or activates behavior. In Hull's view, a reduction or satisfaction of a drive is the sole basis for reinforcement. The strength of the drive can be empirically determined by the length of deprivation or by the intensity, strength, and energy expenditure of the resulting behavior. Hull considered length of deprivation to be an imperfect measure and placed greater emphasis on response strength. Hull postulated 2 kinds of drive. Primary drives are associated with the innate biological need states and are vital to the organism's survival. Primary drives include food, water, air, temperature, regulation, defecation, urination, sleep, activity, sexual intercourse, and pain relief. Hull recognized, however, that organisms might be motivated by forces other than primary drives. Accordingly, he proposed that the learning or secondary drives, which relate to situations or environmental stimuli associated with the reduction of primary drives, and so may become drives themselves. Thus, previously neutral stimuli may acquire the characteristics of a drive because they are capable of eliciting responses similar to the responses aroused by the primary drive or original need state. A simple example involves touching a hot stove and getting burned. The painful burn caused by actual physical damage to the body's tissues produces a primary drive, the desire for relief from the pain. Other environmental stimuli associated with this primary drive, such as the sight of the stove, may in the future quickly lead to withdrawing the hand when this visual stimulus is perceived. In this way, the sight of the stove becomes the stimulus for the learned drive of fear. These secondary or learned drives that motivate our behavior develop from the primary drives. Hull's learning theory focuses on the principle of reinforcement, which is essentially Thorndike's law of effect. Hull's law of primary reinforcement, which is essentially Thorndike's law of effect, states that when a stimulus-response relationship is followed by a reduction in need, the probability increases that on subsequent occasions the same stimulus will invoke the same response. Again, the law of primary reinforcement is when a stimulus response or an SR relationship is followed by a reduction in a bodily need, the probability increases that on subsequent occasions the same stimulus will invoke the same response. Reward or reinforcement is defined not in terms of Thorndike's notion of satisfaction, but rather in terms of reducing a primary need. Thus, primary reinforcement, or the reduction of a primary drive, is fundamental to Hull's theory of learning. Just as his system contains secondary or learned drives, it also deals with secondary reinforcement. If the intensity of the stimulus is reduced because of a secondary drive, then that drive will act as a secondary reinforcement. Clark Hull in 1941 said, "It follows that any stimulus consistently associated with a reinforcement situation will through that association acquire the power of invoking the condition inhibition, i.e. reduction in stimulus intensity, and so of itself producing the resulting reinforcement. Since this indirect power of reinforcement is acquired through learning, it is called secondary reinforcement. Stimulus response or SR connections are strengthened by the number of reinforcements that have occurred. Hull created the strength of the SR connection habit strength. It is a function of reinforcement and refers to the persistence of the conditioning. Again, the habit strength is the strength of your stimulus response connection, or the SR connection, which is a function of the number of reinforcements. Learning cannot take place in the absence of reinforcement, which is necessary to bring about a reduction of the drive. This emphasis on reinforcement characterizes Hull's system as a need reduction theory, as opposed to Tolman's cognitive theory. So, as a leading exponent of neo-behaviorism, or new behaviorism, Hull was the target of the same attacks aimed at Watson and other behaviorists. Psychologists who opposed any behavioral approach to psychology included Clark Hull in the enemy camp. His system was criticized for its lack of generalizability. In his attempt to define variables precisely in quantitative terms, Clark Hull necessarily operated on a narrow plane. He often formulated postulates from results obtained in a single experiment. Opponents argued that it is difficult to generalize to all behavior on the basis of specific experimental demonstrations, such as, quote, the most favorable interval for human eyelid conditioning, or the weight in grams of food needed to condition a rat, end quote. Although quantification is commendable, Hull's extreme approach reduced the range of applicability of his research findings. Nevertheless, Clark Hull's influence on psychology was substantial. The sheer quantity of research inspired by his work, as well as the large number of psychologists he influenced, assures that his stature in the history of psychology is manifest. Hull defended, extended, and expounded the objective behaviorist approach to psychology as no one else had ever done. One historian wrote, "It is not often in any field that a true theoretical genius comes along. Of the very few to whom psychology can lay claim, Clark must surely rank among the foremost." End quote.